afternoon and welcome to the webinar series organized by Parul University. Today we have among us Mr. Paresh Mewawala. Sir is Director of Enpro Envirotech and Engineers Private Limited. Sir is postgraduate in Chemical Engineering from IIT Mumbai from 1995 batch. After obtaining experience in project execution and design for 3 years, he started his own company to provide engineering services in a field of environmental and process plant related field. He is at present heading company with strength of 100 plus staff and having verticals such as environment legal consultancy, design engineering and project management, environment laboratory, plant and equipment supply, calibration labs, and operations and maintenance. He has under his leadership completed approx 3 biomedical treatment sites, 10 common effluent treatment plant, and 3 treatment, storage and disposal facilities site. So, on behalf of Parul Institute of Engineering and Technology, Diploma Studies, Parul University, we welcome you, sir.
Yeah, thank you very much for your introduction and giving me opportunity to get you through the brief about the industrial waste management for environmental engineers and chemical engineers.
Yes, sir.
I will start let me share.
Yes.
Presented. Okay. I think, is it visible?
Yes, sir. It is visible, sir.
So my talk today is an overview on industrial waste management for beginners. Mainly students who are graduating from institutes, or mainly freshers who have graduated and started their training in industries. So this topic of discussion will mainly cover various legal requirements and permission related to environmental aspects, then wastewater treatment, air pollution control, industrial solid waste management, biomedical waste management, and a brief about what is CETP, CHW, TSDF, CBM, WTSF. So, and my discussion will not be focused so much on detailed technical explanation of various systems. Focus will be sort of a brief review of various environmental aspects and procedures required for various permissions, as well as an engineer, when he enters to industry, he should be aware about how to manage the environmental issues in the industry. So starting with first slide, any new industry or existing industry will have 3 phases. First phase will be environmental permissions, that is pre-operations. So if any new industry is coming, or any existing industry who is going ahead with the modernization or expansion activities, they need to take various environmental permissions, such as environmental clearance from MOEF and CC, then consent to establish from State Pollution Control Board, consent to operate, or CC&A, we call it Consolidated Consent and Authorization from State Pollution Control Board. Then once these permissions are in place, specifically when environmental clearance and CTE are in place, industries are, along with the industrial infrastructure, industries are required to set up environmental infrastructure. Environmental infrastructures will consist of wastewater treatment plant, air pollution control systems, solid waste management and disposal arrangement, then sewage treatment facility in certain cases, then health and safety related infrastructure, firefighting related infrastructure, and environmental laboratory. Once these infrastructure are set up in the industry and industry obtains CTO, consent to operate, then the post operation requirement is to comply with the conditions of all permissions by industry. Then look forward for various opportunities related to resource recovery, recycle and reuse for sustainable operation of their industry, and then continual improvement in environmental performance. So these are the general three phases for an industry where which includes a starting of industry to operation phase of industry. So we will have a brief review on what are the legal requirements. So as far as permissions are concerned, the environmental related permissions are concerned, the apex body is Ministry of Environment and Forest, and Ministry of Environment, Forest and Climate Change, Government of India, which is at Delhi. And the implementing agency sits at Delhi is Central Pollution Control Board, who has regional offices in various states. So CPCB is basically an implementing and monitoring agency as per the environmental laws and various notifications published by Ministry of Environment and Forest. The same time, each state has their forest and environment department at ministry level, and each state has their state pollution control board, call it SPCB, and state-wise it is called GPCB for Gujarat Pollution Control Board, MPCB for Maharashtra Pollution Control Board, MPPCB for Madhya Pradesh Pollution Control Board, and so on. For each state, there are pollution control boards attached with their forest and environment department, and pollution control committee for union territories. So these are the government bodies and authority from where permission, environmental related permissions are to be obtained. Now, what are the permissions and legal requirement? So let us first discuss about environmental clearance. So if you go to website and search EIA notification, EIA 2006, which is the latest EIA notification, and which is amended from time to time, and latest amendment comes as it progresses ahead. As per this notification, there are certain category of industries. They have given a category of industries which are divided into category A type of project and category B type of project. Now, category A type of project, as per notification, needs to take environmental clearance from central government, that is at Delhi. And category B type of projects needs to take environmental clearance from State Environmental Impact Assessment Authority. It sits at each state. So each state has SEIAA, that is State Environmental Impact Assessment Authority, who handles category B type of project. So this environmental clearance is not applicable for all industries, but there are category of industries defined by Ministry of Environment and Forest who falls under this EC requirement category, which is clearly specified in notification. So one can go to website and download this notification and study this. There is a detailed procedure of how environmental clearance is obtained, what are the stages, and what are the application, how the application needs to be done. Everything is given in that notification. And this entire environmental clearance procedure is an online procedure, and it is application, uploading of document, everything is done online. So what is, in brief, I will explain only in brief what are the stages of projects. Now, where it is applicable? It is applicable for all new projects or existing projects who goes for expansion or modernization, or they go for change in product mix, and falling under category A or B as per EIA they needs to take prior environmental clearance. Now, what is prior environmental clearance? Prior environmental clearance is a clearance which you need to take before you start any new project construction phase or expansion phase. So you have to first take the permission and only you can start the construction work. And EC process, as per notification, you can go through that. And after that, they issue environmental clearance. So these are the stages. In big letter, all details are given in notification, but these are the major stages which one should be aware of. Like for environmental clearance, you apply for terms of reference, which is online, and in which you have to give your project details, where it is located, what are the environmental features, what are likely to be the pollution load, what is the production capacity, what is going to be your effluent management system. It's a preliminary project details with project feasibility report. A small report you have to upload and apply for TOR. Then on this application, either committee, based on their scrutiny committee, grant terms of reference, standard terms of reference, or if they feel, they call for a presentation. If the project is very critical and it is not sort of conventional type of project, then they call for presentation for terms of reference. So you have to, one has to go to for presentation to either Delhi at central level committee or at state level committee, depending on type of project. Once TOR is issued by the committee, now what does terms of reference specifies? Terms of reference specifies that what you need to study in EIA report. So everybody, people who are in environmental engineering field must be aware about what is environmental impact assessment report. So I'm not talking about what environmental impact assessment report consists of, because that you all must be aware of. But what I am discussing is that TOR consists of number of points which needs to be included in EIA report. That is, the scope of EIA report is finalized in terms of reference. So based on that TOR, EIA study needs to be conducted. Typically, one season environmental monitoring, that is winter, summer, and post-monsoon season. No monsoon season is not allowed for environmental monitoring. So 3 seasons are allowed for environmental monitoring for 3 months. Based on EIA study, a draft EIA report in compliance with the TOR condition is submitted for public hearing. Now, public hearing may not be applicable for all the projects, specifically projects who are already in industrial estate who have already taken environmental clearance of their own industrial estate, and the project falls under that, those notified industrial estate, those projects generally do not need public hearing. But if committee feels that public hearing need to be conducted, then public hearing is required. Public hearing, after public hearing is a process of about 45-60 days process, where in 10 kilometer area, public villagers and local public can come, and they can submit their grievances, their requirement and their apprehensions about the project, and which project proponent need to answer, and wherever required they need to comply with their requirements. So once the public hearing is completed, and based on the public hearing minutes prepared, a final EIA report is prepared, which is submitted to committee for appraisal. So again, committee calls for presentation for final appraisal of EIA report. It is called a presentation for getting environmental clearance. So in that presentation, project proponent along with their consultant has to go and present the case, and based on the presentation, based on the details submitted in EIA report, EC committee may recommend for grant or denial of the environmental clearance, or they may ask for additional information also. And from this onwards, if it is granted, process is ended. If it is denied, again process is ended. And if additional information is required, then again you have to submit. One has to submit an additional information and go for another set of presentation. So this is the EC process. This takes about 6 months to 12-month time, and maybe sometimes it takes more time also. Now, once environmental clearance is clearance obtained given by Ministry of Environment and Forest from a central government as well as from state committee, state authority. Now, all projects who are polluting projects those projects may fall under EC requirement or may not fall under EC requirement. Has to get the permission from State Pollution Control Board. It is called a consent to establish application. So even the project does not fall under EC requirement, they have to take consent to establish, which was earlier called NOC from the board. So again, this is an online procedure, and one has to apply for CTE, and based on the site visit, scrutiny of the proposal, State Pollution Control Board may grant consent to establish. So this is another procedure. Now, once consent to establish is received or EC is received, environmental clearance is received, a project is considered to be cleared for starting construction activity. So then the phase of project execution comes, where industrial setup is done, then pollution control systems are installed, and once the project is ready to start after the execution, industry has to apply for consent to operate. So in that consent to operate or CC&A, in consent, once industry apply for consent to operate, there is a visit of officers and they check the compliance of industry according to the conditions laid down in environmental clearance and consent to establish. Once they are satisfied with they confirm that industry has fulfilled the requirement as per application, they grant consent to operate to industries, and then industry will start operating the plant. So, and sometimes if they are not satisfied with the implementations, they may ask industry to complete the implementation. So these are the three basics permission for from establishing industry to starting of industry, which are EC, CTA, and CPO. In addition to that, industry are required for approval of MAP from local authority, permissions from factory inspector, including fire NOC, on-site, off-site emergency plan, risk assessment study, HAZOP study, etc. Those local level permissions are required, but which are not part of environmental permissions, but it's a supportive document, and it is as necessary as environmental permission. So I think this is what I have covered about the various legal requirements to from environmental point of view to start an industry. Now I will go to wastewater treatment plant. Now, as we discussed that during your permission level, you have to give all details of what type of wastewater is going to come, what type of effluent treatment plant you are going to propose. So that designing and planning of wastewater treatment facility will come right from the stage of application. So for obtaining any permissions, design of adequate, robust, and sustainable wastewater treatment scheme is very essential, which can address the requirement of disposal norms and mode of discharge for that specific site. So, question is how to arrive at suitable wastewater treatment scheme for new industry or existing industry proposing for expansion. It is very important for newcomers in this field has to understand that any wastewater treatment plant needs a design or implementation needs a thorough study of the wastewater being generated from the industry. And it is very essential that adequate laboratory level knowledge is required by environmental engineer. Maybe they are not involved in testing, or they may not do real analysis of the wastewater, which is generally done by environmental chemists. But any environmental engineer has to understand what is the significance of various parameters in wastewater. What is the significance of knowledge of laboratory level treatability study, which from based on which these it is our experience that in these analysis and generally for them this laboratory level knowledge becomes it's not a priority. It's in that is our knowledge, but it is very important to have that laboratory level knowledge also. So what is approach? Like when one has to design a wastewater treatment scheme, the approach should be obtain a mass balance from project proponent for each product. Then, because if you are planning a new industry, or if you are even if in existing industry, if somebody is, if one environmental engineer is working and if they are going for expansion of the plant, then it is definitely very important to understand that what type of wastewater quality is going to be generated from that additional production. So mass balance of product, to understand the mass balance of product is very important, and based on mass balance of the product, it is important to derive the water balance and of that particular process and assess the wastewater generation and identify and quantify each wastewater streams. Do not club all wastewater streams together and identify if in one plant, if one is generating 4 different type of wastewater streams, identify them separately, analyze them separately. So important is that representative sample of each streams of from project proponent or from the plant is required. Now this is a very challenging work, because sometimes when industry is coming new and industry is with new product, it is very challenging to get the representative samples to analyze in lab. So, but somehow with the project proponent or based on the experience or based on the context, one has to find out a representative samples from identical industries who are already under operations. So this is a challenging, but one has to overcome this challenge. And in absence of samples, assess quality of wastewater based on past experience or reference or samples from similar industries. Okay. Then why I told in earlier slide that segregate all streams generated from a single plant. Then divide streams between 4 major categories like high TDS, low COD, low TDS, low COD, low TDS, high COD. And then based on higher concentration of compounds such as heavy metal, phenolic compounds, ammonical nitrogen, hexavalent chromium, any such parameters which need separate pre-treatment prior to common treatment. It is essential, because if you club all stream together, the treatment will become very difficult, because some effluents are low in concentration and their treatment is relatively simpler than the effluent are having higher concentration. So if you mix all effluent together, your overall treatment become very difficult and sometimes become infeasible and very costly to operate. So it is important that all streams to be segregated at source, and then analyze them separately and segregate them in different category, and then work out a treatment scheme which becomes the most optimum treatment scheme. Now, based on this segregation, one has to finalize what is going to be design basis for the wastewater treatment plant, which consists of quantity and characteristic of each streams, and of course, mode of disposal of treated wastewater. Now, what are the mode of disposal which can be like disposal on surface water flowing to sea, like you can say khadi, or disposal, and norms of disposal on surface water is given by State Pollution Control Board. But to tell you, nowadays there is no such permission has been issued to dispose the wastewater on surface water. This was earlier, and earlier days this was being granted, but now recently no such permissions are granted. Then disposal of two CETPs. There are CETPs are common effluent treatment plants. So CETPs is a facility where up to the CETP inlet norms, industry has to bring down that level of pollutant level and then supply effluent to CETPs. And CETP will treat and then dispose it further. Then disposal to deep sea, this is another alternative. But for a single industry, this may not be possible. This disposal to deep sea can be by a CETP or can be by very large industry. Then zero liquid discharge. What is zero liquid discharge? Is there is no disposal from the industry. Entire wastewater is treated to that level that the recovered water produced can be recycled back to the industrial unit. So it is called a ZLD unit, where there is a landlocked area, where states which are under landlocked, like Gujarat, we have sea and we have a disposal facility, but state like Madhya Pradesh, state like these North Indian states, they don't have any disposal point. And disposal, like state like Rajasthan, they don't have disposal point. They cannot, because as per the national policy, a treated wastewater cannot be discharged into river also. River water which is used for drinking purpose. So they have to go for zero liquid discharge. So zero liquid discharge from last 5-10 years, this has become a more preferred for many state pollution control boards. Then partial recycling, some effluent is discharged and some effluent is partially recycled. So based on the mode of disposal available for the location of the industrial unit, one has to select, and accordingly treatment scheme has to be designed. So I have prepared a slide to show some typical treatment schemes for different type of wastewater. For example, this is for a low COD and a biodegradable wastewater, and having TDS also on lower side. So these may be from textile industries or paper industry and industries who is generating high volume of wastewater. They have generally this type of effluent characteristic, where treatment scheme is primary, where one does the physico-chemical treatment and chemical dosing and remove the suspended solids in clarifiers, and after that a soluble COD and BOD is reduced in biological treatment, which can be anaerobic treatment or combination of anaerobic and aerobic treatment. I'm not going on those details because those things you have studied. I am focusing on how to arrive at the treatment scheme. So then one has a tertiary treatment, and after tertiary treatment, effluent can go for disposal or partial recycle. So this is a typical conventional effluent treatment scheme. Probably you have studied in your courses. Then this is the wastewater treatment. Another type of scheme is like when you have effluent of high TDS level, more than 15,000 milligram per liter, and low, medium, or high COD. Generally, when the TDS level goes above 15,000 or near to 20,000, biological treatment becomes non-feasible. It doesn't work. That is our experience. And you will find number of chemical industries, pharmaceutical industries, pesticide industries who generates this type of effluent. And conventional effluent treatment plant doesn't work there. So one has to go with another type of wastewater treatment scheme where after a primary treatment, of course, you have to remove suspended solids, sludges prior to the treatment, and so one has to remove in primary treatment, and then you have a membrane-based treatment where one use ultrafiltration membranes, nanofiltration membranes, and RO membranes to separate TDS and COD from the wastewater. And the permeate that is a good quality water from the membrane separation is sent for recycling, and the reject that's a concentrated stream from membrane system is much higher in concentration of TDS and COD, is subjected to evaporation in multiple effect evaporators or mechanical vapor recompressors with dryers. Here, energy like steam is used for evaporation, where from the concentrated stream by evaporation method, water is recovered in a condensate form, which is subjected to recycling. So this is sort of a ZLD process, zero liquid discharge process, where practically one does not have a discharge of liquid wastewater from the premises. Only sludges, salts, and chemical sludge are generated, which need to be disposed of. Another set of ZLD scheme is uh, an effluent where there are a lot of specifically API, that is a pharmaceutical intermediate industries, where a lot of low volatiles are consist of. Now, people who are in chemical engineering, they know what is low volatile, what is high volatile. Low volatiles are generally solvents which has boiling point less than water, and high volatiles are chemicals which has boiling point more than water. So this is how we understand. And sometimes when such low volatiles, solvents like methanol, acetone, solvents are when present in the wastewater, the membrane system does not work. Like here, you have seen the membrane system up front of membrane system doesn't work because those membrane system gets damaged in presence of solvent. So in that case, one has to directly go to evaporators, that is a steam operated equipment, recover the condensate, which will be contaminated with low volatiles and COD. That needs to be given a biological treatment followed by a membrane treatment. After membrane treatment and after the good water will be recycled, and reject from the membrane treatment will be fed back to evaporator. So this is also a sort of ZLD scheme. Second ZLD scheme, you have an evaporator followed by membranes. Evaporator followed by biological treatment followed by membranes. So these are the conventional these are the ZLD, typical ZLD schemes used for pharmaceutical industries, chemical industries, pesticide industries, where effluent are very high in concentrations. Here, conventional biological treatment does not work. Then now we come to another type of industrial effluent, where industrial effluent consists of inorganic pollutants like heavy metals, chrome, etc. Those are very toxic and does not consist of organic pollutants in large quantity. So generally, this type of effluent gets generated from engineering industry, this coating industry, and electroplating industries. This type of effluent gets generated. So here, many heavy metals may be present. If let's say chromium is present, so for each type of metal, there is a different set of treatments generally, which needs to be finalized at laboratory level and based on experience at for the past effluent treatment plant. Generally, for let's say chrome hexavalent chrome is present in the effluent, so you have to first reduce the chrome to trivalent and then precipitate out from the wastewater by using reducing agent. So these things happens in acidification. Similarly, some metals like lead, arsenic, etc., some metals only get precipitated in acidic condition. So you have to remove those metals in acidic condition and then again bring the effluent to alkaline pH to remove other metals like copper, nickel, zinc, etc. in alkaline condition. So this is basically a chemistry-based, more or less chemistry-based treatment process where inorganic effluent is generated, and finally the all metal comes in a sludge form and which needs to be disposed of to landfill site. Similarly, one example is about the phenolic compound treatment. So phenol is very toxic for biological treatment. So before a biological treatment, if the effluent consists of a lot of phenols or phenolic compounds, that needs to be removed or knocked off prior to biological treatment. So this can be achieved by using phenol recovery unit, phenol distillation unit, or ion exchange by recovery by ion exchange method, or phenol oxidation using Fenton treatment or ozonation treatment. So you have to bring down phenol level to at least less than 5 milligram per liter before the biological treatment. And sometimes in some of the effluent, phenol can be as high as 100 milligram per liter or more than that. So in such effluent needs such type of pre-treatment. So many specific effluents are there which will need a pre-treatment prior to taking that effluent to conventional effluent treatment. So these are the some examples of real life examples. Those are typical treatment schemes. These are the real life example of various treatment schemes like low COD, low TDS. As I told earlier, that equalization, then primary treatment, biological treatment, then tertiary treatment, and a partial recovery of wastewater. This is for one of the CETP which we have done. This is another example of another CETP where you have multiple coming from chemical industry, and you have multiple type of effluent. So effluent is transported to CETP through tankers, designated tankers. Tankers are analyzed. Based on analysis, tankers are stored in different storage tanks, and from those storage tanks, for specific treatment, effluent is transferred to different section of wastewater treatment line, like C1, C2, C3, this different section of wastewater treatment plants. So this is very good examples where you have to collect the wastewater in segregated form, store it in segregated form, and treat as per the requirement in various section of CETP. So this is one CETP which is under operation. Similarly, this is another CETP where it's about 5 MLD CETP, and where you have 50% of effluent is subjected to zero liquid discharge, and effluent is sent back to member unit industries, and balance effluent is discharged. So these also consist of primary treatment, that is a chemical addition, then biological treatment, and then tertiary, and then discharge. And part of this stream goes to tertiary treatment plant, consists of DEF, reverse or RO plant, multiple effective operator, and here effluent is recycled back. So we discussed all those examples and typical schemes in earlier slides. Now this is the typical plant for one of the API unit, where, as I told, the entire effluent is subjected to evaporators first, and then it is subjected to ozonation, biological treatment, and RO plant. So this is another set of. So regarding wastewater treatment, the presentation ends here. And what I mean to say that treatment scheme is not universal. It's not common. Like it's not common for all effluent treatment, for all type of effluents. One has to select a treatment scheme based on the quality of the effluent, based on the segregated stream analysis of the effluent generated from specific industries. So one has to design a treatment scheme which is robust and sustainable. So robust means it should withstand the requirement without any hiccup in the operations. And sustainable means it should also meet the must be at operated at optimum cost level. So it is sustainable for industries also, and suitable for available mode of disposal at the location of industry. And a chemical engineer or environment engineer who works on this, because this work till this point comes from a process, that is a environmental engineer or a chemical engineer. They should be able to do basic sizing of the major component of the effluent treatment unit. Based on the once treatment scheme is done, what is the requirement is they should be able to do basic sizing of the effluent treatment unit. Now this comes under your core study, which you have to study in future, and you have to learn how to size the equipment. Then should be able to work out what is going to be the consumption of chemical and power, to work out what is going to be the operating cost. Similarly, estimate what is going to be the sludge generation. That's a primary sludge, biological sludge, and tertiary sludge generation. And estimate what is going to be the operating cost of the plant. And also estimate what is going to be the space requirement. So this basic requirement, one should be able to arrive at during their training in the industry, wherever they work. They should focus that they should learn how to at least prepare this document, so that this completes almost 30-40% of the execution work. Because after that, it's all conventional, like civil design, mechanical design, electrical design, which any engineer can do. But this is the process which only environmental engineer and chemical engineer, or maybe environmental chemist will do. So these people has to learn how to do this work. Now let us come to air pollution control. So this I'll go very fast. Like what are the type of pollutants? One has a primary pollutants such as carbon monoxide from water and exhaust of SO2, and secondary pollutant which forms in the air when primary pollutants react or interact, that is ground level ozone. So these are the various pollutants, air pollutants, which segregated as a primary pollutant and secondary pollutant. I think you all know all this theoretical details, so I will skip this. These common pollutants are industry specific. These are some industry specific pollutants which are common, like solid waste landfill sites are PM, particulate matter, acid gases, carbon monoxide, NOx, toxic organics, DAX influence. Then petrochemical complexes will have SO2, particulate, smoke, hydrocarbon, H2S. This data is very important, because when you work on some industry, or when you go and work in some industry, you should be aware that this type of industry has likely generation of this type of pollutants, and that should be at back of your mind. Like food and agriculture industry will have, like fertilizer will have NO, SO2, ammonia, particulate matter. Pesticide will have organic compound and PM. Sugar industry have PM, NOx, CO, CO2, SOx, ammonia. Leather industry have sulfide, VOC, ammonia, H2S, chromium, PM. So this one has to keep at back of their mind. Now, what are the different technological alternatives for air pollution control? So air pollution problem has three options for control. One is improve dispersion. Second is reduce emission by process change or pollution prevention, and third is use downstream pollution control device. So first two options we will not discuss much. We will discuss on third option only. That's a downstream pollution control device. Now in first alternative, like improve dispersion. So if you all have studied the dispersion analysis and how the flue gas from the stack goes to atmosphere and how the dispersion takes place there, and what is going to be ground level. GLC is a ground level concentration. So that is sort of like you increase the stack height, you increase the dispersion, and your GLC will come down. So this is like just sort of a dilution of flue gas into more volume of ambient air. But improving dispersion is not permitted as substitute for industrial emission reduction. So this one has to keep in mind that dilution is not the solution. One has to treat the either wastewater or air pollutants before it is discharged to environment. Then another option is intermittent control scheme, like you must have read in newspaper, like staggered vehicle traffic in Delhi to reduce the ambient air, to improve the ambient air quality, and then sometimes not allowing operations of incinerators at night time in area of certain industrial estates near to residential area. Then this is also very important, process change and pollution prevention. So sometimes you control the pollutant at source, you change the raw material so that your emission level goes down. For example, oxygen based melting process instead of air based melting process, resulting in high concentration of SO2, leading to feasibility of sulfuric acid production. So your sulfur dioxide, which was earlier emitted as a pollutant when air was used, because it was in small concentration, you have to put a pollution control equipment. Now, instead of air, when you use oxygen, you generate SO2 at higher concentration, so you can install a sulfuric acid plant to convert SO2 to sulfuric acid plant. So this is like an example of a process change. Similarly, switching to cleaner fuels. Similarly, carpool, mass rapid transportation system, work from home. Maybe that is a compulsion, but these are the various alternatives for process change and pollution prevention. Now, use of downstream pollution control devices. Now, this is about, we will discuss, rest of our discussion will be on this topic only. So again, as we discussed on wastewater treatment plant, the methodology for air pollution control system, selection of air pollution control system is again same. You have to get an input from industry for new system, survey and measurement and data collection at site for existing system, and one must be aware about the statutory limits permitted to industry for emission. How to collect, survey, measure data collection at site for existing system. Then that brings in picture the stack monitoring, skill of stack monitoring, study and testing of process emission, testing of flue gas emission at laboratory after sampling. So again, here, engineers and chemists must be, even if they are not in this field, or if even in future they are not doing themselves environmental monitoring, they must be aware what is the measurement and how data is collected and what are the significance of various parameter. Then one has to fix the design like flow data, operating condition, pollutant concentration, inlet, what is going to be outlet, verification of design basis for identical industry based on past experience and reliable references. This is also very important, because when you do the first time selection of equipment, you must verify from various data for this type of industry what type of pollution control systems has been installed, what were their problem, what were their past experience, so that you can improve your selection. Then design or selection of air pollution control scheme, addressing what is going to be removal efficiency, what is going to be variation in process condition, because input may change up and down. Then non-homogeneous pollutants, whether is there any possibility of resource recovery, whether you can recover pollutants and reuse as a byproduct. Then space requirement, what is going to be operating cost versus capital cost, treatment and disposal of secondary pollutant, because air pollution, as the wastewater treatment plant generates the solid waste, air pollution system also generates either liquid or solid waste. So disposal of secondary pollutants and material of construction. So these are there are various particulate control treatments like gravity settlers, cyclone separators, bag filters, ESPs, Venturi Scrubbers, spray towers. So I will, so gravity separators, these are a lot of technical details which I think presentation I can share and people can go through this. Cyclone centrifugal separators are, everybody is about the cyclone separators. Then this is a multi-cone type of cyclone separators where you have better efficiency than single type of cyclone separators. Then you have bag filters. Bag filters are these are different type of bag filters, reverse pulse system type, and there is a mechanical shaker type of bag filter where particulate matter is filtered on the bag surfaces and which is recovered by reverse pulsing of air. So these are the bag filters for collection of finer particulate matters. These are various design criteria for the bag filters I have given. What are most important is gas to cloth ratio and what is going to be design pressure drop, what is going to be outlet particulate matter. This is a there are these are the properties of various bags used for the bag filter, for what type of what temperature they can withstand, and based on the process condition, one has to select the bag. Then uh, then this is there is an electrostatic precipitator. Electrostatic precipitator is the highly efficient equipment for removal of particulate matter. Bag filter and electrostatic precipitator and cyclone separators are designed for removal of particulate matter. And these are the various design criteria for electrostatic precipitator for different type of dust like utility fly ash, pulverized coal fly ash, sulfuric acid mist, gypsum, open hearth furnace. And because there are dust which are very low in conductivity, they have a lower removal efficiency. Dust which are high in conductivity, they have higher removal efficiency. So accordingly, ESP is sized. ESP has multiple stages of ESPs are generally installed, 3 stage or 7 stage or 5 stage of ESP to achieve the very high removal efficiency of 99%. Generally, power plant and large boilers have ESPs. Then one has a Venturi scrubber. Now, what we discussed is the dry removal. Now, this is a wet removal. This is a Venturi scrubbers. Venturi scrubbers is a wet scrubbing system which is used for simultaneous removal of particulate matter and pollutants, gaseous pollutants. So these can be fixed throat type Venturi scrubber and variable throat type Venturi scrubbers for removal of particulate matter and gases. So advantages are this is smaller in size than bag filter and ESP. Simultaneous capturing of particulate matter and SO2 HCl can be handled in single equipment. It is a robust equipment and less chances of failure. But what are the disadvantages? Disadvantages: operating cost is high. Then it consists of a very large quantity of secondary pollutants, that is wastewater, consisting of a lot of dust. So that needs another treatment plant to handle it. So, like in dry scrubbing, you get a dry dust at the bottom. Here, you get a liquid slurry at the bottom, which needs to be treated again. So, one can follow this guideline for selection of technology. Like cyclone separator can be done with when particle size is 10 micron and above, and overall efficiency is 70 to 80%. So, capex one is the lowest, and 3 is the highest. Okay, so capex and opex both are lowest. Multi-cyclone separator, you have a 5 micron and above particle size, and you need 70 to 80% removal efficiency. Bag filter, when up to 1 micron particle size, you need a bag filter. Then ESP up to 2.5 micron, 99%, and pressure drop is very low. So it has the highest capex, but the opex is lowest. ESP at that efficiency. Like if you see the bag filter, your capex is at number 3, but opex is also at number 2. So Venturi scrubber, you have again capex is very low, but opex is very high. ESP plus bag filter, like sometimes you have to go with combination ESP plus bag filter, where your capex is at 4 and opex is at 2. So depending on the process condition, type of dust, type of volume of process gas, equipment combinations are selected. Similarly, this is one example, like how complicated can be the air pollution control system. This is for hazardous waste incinerators. Here you have major pollutants like particulate matter, SO2, HCl, NOx, heavy metals, vapor, VOCs. So these all type of air pollutants are available in the gas incinerator, where you have multiple stages of air pollution. Like after your combustion and waste heat recovery, you have a gas quencher. Then your one has a dry scrubber with lime powder injection. 60 to 70% SO2 HCl is recovered, followed by activated carbon injection for removal of VOC. Then one has a cyclone separator, then bag filter, then low pressure of Venturi scrubber, then wet ESP. So if you see, it consists of all equipment in a single plant, because the emission norms are very stringent, generally, and emission concentrations are very high. Similarly, there are other options also, but again, there are multiple air pollution control equipments. So in the biomedical waste incinerator, one has Venturi scrubber, packed bed scrubber, activated carbon column. This is a coal-fired boiler. One has a wet scrubber and dry scrubbing system, bag filter followed by wet ESP, cyclone ESP followed by wet scrubber. So here also you have combination of equipment as per the requirement. Now process emission. Now this is very important about the pollution control followed by resource recovery, where you have a gas containing, when you have a gas containing sulfur dioxide, you have and your adsorbent as a sodium hydroxide. So you generate a byproduct having a mixture of sodium sulfide and bisulfide, which is used in the process. So you scrub it and achieve the required concentration and recycle this sodium sulfide and bisulfide to the process as a byproduct. So this is a very good example of your resource recovery from the pollutant. And this is being implemented and operating at many places. This is the scheme provided. Similarly, HCl also, you can scrub HCl and generate 30% HCl and reuse in the process. So this is also resource recovery and reuse of pollutant. Similarly, ammonia gas, you can generate ammoniacal liquor, which is raw material for amination reaction. So this goes as a resource recovery. So conclusion about air pollution control system is selection of air pollution control technology is a problem specific, and when technology is selected, basic knowledge of pollutant should be there. Operating cost must be addressed, and cost of disposal of secondary pollutant must be addressed. Correct. So now we very quickly, I think we have very less time. We very quickly go for industrial hazardous waste management. Now, if you have seen during the wastewater treatment, you generate solid waste. During the air pollution control treatment, also you generate solid waste. So the disposal of industrial hazardous solid waste is very important. For that, one can go to Hazardous and Other Waste Management Rules 2016, which is available on website, and which defines how waste should be disposed of. In general, industrial hazardous waste generated from manufacturing process, wastewater treatment, air pollution control system, and various material handling system, and any reject material from industry. So these are the when the hazardous waste is generated, it is stored in dedicated storage area provided with fire detection, auto sprinkling, this impervious liner at the bottom covered from soil, top and side, so that it does not come in contact with water or rainwater or outside water. So it has to be stacked properly and be at the industrial site. So such hazardous waste storage area is mandatory requirement for storage of industrial hazardous waste. Minimum 90 days storage capacity has to be provided, and this hazardous waste is then disposed of to a common hazardous waste disposal facility as per the qualification of the waste. Through this dedicated transport vehicle, all container of the hazardous waste must be labeled properly as per the hazardous waste rules, and they must be identified. A landfill operator must be able to identify this hazardous waste based on the label. So these are the routes for the disposal methods for the disposal of hazardous waste at landfill site. Some of the hazardous waste which qualifies can directly go for landfill, secured landfill. Then some of the hazardous waste will need a stabilization treatment for stabilization of movable particles like heavy metals, prior to landfill. Then hazardous waste which are high in organic content, which is having high calorific value, more than 2,500 calorific value, and need to dispose of through hazardous waste incineration. And hazardous waste, some of the hazardous waste after pre-processing can go to cement industry for co-processing. So basically, there are three ultimate disposal route. One is to secure landfill, maybe with treatment or without treatment. Second is incineration. Third is the to cement industry. These are the photographs for typically just to have an idea how the landfill looks. These are you have a bottom liners as per the CPCB guideline. This landfill you can see is a closed landfill. You have a grass on the top. This is at the bottom a filtration system provided landfill. This I will not go to this highly technical. You can share the presentation, and this is a bottom liner. How there are two liners are provided at the bottom. HDP liners, two level of HDP liners are provided at bottom, so that hazardous waste remains at the top and does not come in contact with the natural soil. Similarly, these are the liners provided at the side slope of the landfill, and the liner provided at the top after the capping of waste. When the waste is filled up to this point, then top also these liners are provided. So this is a stabilization treatment, like when hazardous waste consists of heavy metals which can leach out with the water in the landfill, they needs to be fixed by addition of binders like cement or fly ash. So hazardous waste is mixed with cement fly ash. They are mixed in mixers. They are put in the stabilized waste modules, and then after leachate test only, then these modules are sent to secure landfill, so that their leachability is minimized or reduced. This is the scheme for incineration. One can go to incineration will consist of primary combustion chamber, secondary combustion chamber, then series of air pollution control system, which we discussed. These are a practical photograph of large incinerator plants installed in India only, hazardous waste incinerators. Then what is pre-processing for cement co-processing? So in cement industry, if I think you must have studied how the cement is manufactured. In cement industry, there is a rotary kiln is there which operates at 1300 degrees centigrade. So that is a adequate time for that is a adequate the inside operating conditions are adequate for destruction of toxic organic compounds in rotary kiln. So waste which can go to cement industry is prepared at facility by addition of so that a uniform quality of waste is prepared, and that waste packed in bag is sent to cement industry, which goes as a fuel in the cement industry. So by sending waste to cement industry reduces the fuel consumption at cement industry, and this is how it is sort of replacing fuel, and it's a benefit to cement industry as well as nation. Similarly, liquid also blending system schematic flow diagram is provided how liquid can be blended and sent to cement industry. So anyway, this is a short introduction of biomedical waste, where you have generation of waste. Waste is stored in three different categories, and the yellow waste is subjected to incinerator for disposal. Red waste is subjected to autoclaving, shredding, and shredded waste is sent to authorized recycler. Blue waste is cleaning through chemical cleaning and soaking, and effluent is sent to ETP. And this white is autoclaving, sterilization, shredding, and shredded waste is for landfill or for recycling. So what is yellow? Yellow is this all organic type of waste generated from biomedical waste, medical operations. Then red waste is non-chlorinated plastic, this contaminated waste, which is recyclable, which is generally metallic parts, metallic implants, etc., which needs to be autoclaved and then it can be recycled. then the sharps, etc. That also goes to autoclaving and recycling. And then glasswares, glass part, and body implants. That is blue waste. That is also subjected to autoclaving and shredding and recycling. These are typical biomedical waste management facility setup. Just to brief, what is common treatment and disposal facilities? The CETP is a common effluent treatment plant. We call it CETP. It looks like this. This plant is based at Surat only, aerial photograph. Then this is a CSW TSDF is the common hazardous waste treatment, storage, and disposal facility. So this is a landfill, this is incineration, and common biomedical waste treatment facility is this is an incinerator of common biomedical waste treatment facility. So just to have a brief idea about this common facility accepts the waste from the generators and treat them on chargeable basis. Similarly, now post-operation compliances are mainly monthly or quarterly sampling analysis of treated wastewater, stack gas, ambient air, monthly submission of various production details, yearly, half-yearly environmental audit report, compliance report of environmental clearance, details of corporate environmental responsibility, and details of green belt. These data needs to be submitted to statutory authority on regular basis. Thank you. I think I've taken little more time, but now it is over. I'm open for discussion.
Okay, sir. I did not receive any questions from viewers right now. So, sir, it was very informative session, and I think many doubts of students or viewers have been cleared. So, on the behalf of Parul University, we thank you, sir, for giving us your valuable time. So, once again, thank you, sir.
Thank you very much.
Okay, sir.
And if anybody has doubt at later stage also, you
Yes,
can send
yes.
me.
Yeah,
Okay.
I mailed you, sir.
And if you need this copy of presentation, I will send it to you. You can
Yeah,
send
yes,
to
yes, sir. Sure, sir.
interested students.
Yes, sir.
Thank,
Yeah.
thank you.